Online able to see my screen here? Online, am I audible? Yeah. Operations. A short recall what we have done in the earlier class on sets. See, I am not properly defined on any sets. Just then and there I was talking about the terms, but actually when we are talking about the five operations, what are the five operations we have? What are the five operations we were discussing? First one, union. So somewhat we have gone through in detail using the Venn diagram. Actually, for the exam purpose, we'll not be using Venn diagram always. We have to picturize that. That's why I'm using Venn diagram. Whenever you picturize something, it will be registered in your mind clearly. So first one, Venn diagram, you have done in detail. Second, intersection, which also done in detail. And third one, difference. Difference is there. And another one term will be using symmetric difference. Both are different. Okay, difference and symmetric difference. And fifth one, complementary. So complementary you might have studied in your lower classes, but anyway, we'll go in detail. So for union, you remember what we were using for union? What we were using for union? The words either or. Okay, symbol is this U. Actually, it's not U, but we say it as U only. For intersection, we were using inverted U. In terms of wordings, we were saying this is either A or B. Okay, because in future we may be using like neither A or B, either A or B or C. So we'll be just using the twisting terms. When I say either A or B, we are going to use union. Okay. If it is neither, what is either A or B? It should be in A or in B. Sometimes we'll be using like neither A nor B. Okay, neither A nor B, which means it should not be in A and also it should not be in B. So probably um, if I draw the Venn diagram, I go for the shading for A union B. What's the shading? Can you help me out? This one, right? This is for A union B. What it does mean in wordings? It will be either in A or it will be in B. So it can be present over here, it can be present over here, it can be present over here, over here. What about here? Definitely it's not present. What about here? It's not present. Which means if I am talking any element somewhat naming as some A, B, X, Y, is not present in A union B, which means neither A nor. Okay, so actually we'll be writing neither A nor B as A union B the whole dash. It's complementary. What is complementary? Not present. What do you mean by complementary is not in A, which means, for example, A dash if I use, not in B. When I talk about complementary set, I need to know about first the universal set or the sample space. Only if I know the universal set or sample space, I can talk about complementary set. Because complementary sets is not in A. Okay. What do you mean by complementary? It's not in A. Actually, what do you mean by complementary? English wording is if I draw this box, okay. Don't think about Venn diagram. Think this is my classroom now. Okay, so I have this my classroom, and this is the walkway A. Okay, and I have four chairs, four tables, set of tables. One, two, three, and four. One, two, three, and four. And I'm seated over here. Okay, and I have my students seated over here. Okay, for example, I name the student as Mr. A. Okay, Mr. A. Okay, Miss B, Miss C, Mrs. D. Okay, who's that Mrs. D? Okay, actually married. Okay, that's why I'm mentioning Mrs. D. No, okay, Mr. E and what A B C D E F. Okay, some alphabets. So this is the set A, which contains these students in my class: A, B, C, D, E, and F. Is it okay? What about this A dash? Contains not in class. So which means these places might be still occupied, right? There may be some A, there may be some B, there may be some C, D, E, F, G, H, I, J. All these may be occupied in future. So this is called as not in E. That's what A dash. Now understand the term complementary. How many seats, rest of the seats can be filled? The rest of the elements will be called as rest of the seats here. So complementary means complementing. Now go for the Venn diagram. This is my A, for example. This is my A. What can I do? Please try to understand what can I do so that I get the full box. See, this A is this one alone. Okay. What can I do so that I get the full box? I can include some persons here, which means this is what is A dash. It can be some elements, some persons, or anything else. So this unoccupied space is what you call as A dash, which is complementing so that I get the full set. Okay. So complementary means we are trying to get the full set. That's what we call as complementary. Okay. So now I'll go for third one, difference in detail. Then I'll go for the fourth one. Then again I'll come with the concept for fifth one. So we'll go in order. So here, so you need not copy anything. Just listen to me. Difference. The symbol which you use for difference is a small minus symbol. Okay. Usually we use this for subtraction. Okay. When I say it's 3 minus 2, what do you mean? You're not a CA student now. Now you're in LKG, UKG, first standard. How they thought subtraction for you? 3 in the mind, 2 in the finger, then we'll reduce it. The same thing happens here also. Okay. So just think sometimes we have to do like we have to treat ourselves as a CA, completed CMA. Sometimes we have to treat ourselves as doing first standard, second standard. So try to link that concept, how we studied this subtraction. Probably we'll have 3 sticks. You remove 2 sticks, sticks or bar. So what's the remaining answer? 1. See, so easy. The same thing. I have a set A. We are talking about sets now. Okay. Differences all sets. Okay. So we have A. For example, I'll take 1, 2, 3. 3 elements are there in A. 1, 2, 3 can be A, B, C, anything. For my case, I'm taking a very simple example so that you understand the concept very well. I take B, which consists of 1 and 2 alone. Okay. Yes, tell me. What is A minus B? How you do this? Actually, you write how you did here. Actually, you draw 3 lines, then cut 2 lines. So actually, you write the whole of A, then cut. 1 is present, so cut 1. 2 is present, so cut 2. So what is present here? Remaining 3. Is it okay? Okay, fine. Now I change the example. Probably A contains, please be careful, 1, 2, 3. B contains 1 alone. Yes, A minus B. Simple only. Yes, please. I write 1, 2 and 3. 1 is not present here. So we have remaining 2 and 3. So it's quite easy, right? Yes. Now again join. I have A, which is 1, 2 and 3 the same. I have B, which is 1, 2 and 3. Yes, please. A minus B. 1, 2 and 3 all is present in A, but 1 is present in B, so I cut. 2 is present in B, so I cut. 3 is also present in B, so I cut. So it becomes a null set, empty set. Okay. Again, A, say 1, 2, 3. Okay. B, see, what I'm trying to insist here is A is the same. I'm changing the nature of B. Please try to understand in that way. Okay. Now B, uh, null set. Yes, what is A minus B? 1, comma 2, comma 3. Nothing is gone here because there is nothing in B. So the same of A itself is A minus B here. Okay. Only one more. A minus B, where A is 1, 2, 3. B is 1, 2, 3, and 4 is what happens. Sure. That's why I was using the technique. Whenever I write A minus B, write the whole of A, then strike out. I think you did not study subtraction properly in LKG or in first time. See what I was doing. Try to recall that concept. It's 3 minus 2. For 3, you draw 3 lines. Then for 2, you have to cut 2 lines so that you get 1. What I did here, 1, 2, 3. I wrote the whole of A. Then I made to remove the B values, that is B elements. Here also, I wrote the whole of A. I remove B. Here also, I write the whole of A, but there is nothing to remove in B. So as it is. Here also the same. Now, yes, please join. A minus B. Write the whole of A. 1, 2, 3. Now cut B. 1 is present, so cut it. 2 is present, so cut it. 3 is present, so cut it. Where is 4? There's nothing in A. Already there is no 4 here. Then why are you going to talk about 4 here? Is it clear? So what is A minus B in this case? Null set. You need not worry about, I have 4 here. 4 is there, but it's in B. I'm not worried about B. See, my concentration is here. A minus B. Let me repeat it. When I say A minus B, I am focusing A here, but B should not present. When I say B minus A, yes. When I say B minus A, what happens? B should be present. All the elements should be present or no? If that's present in A, you should not have it in B minus A. Okay. So difference is A minus B. How can I represent here? Only in. So this is, I use the wordings only in. So what is here? A minus B. Only in A. Right? What is here? Only in B. Yes, but if you want to make a note of it, yes, you can make a note of it. After scribbling this one, I was working here for A minus B, A minus B, A minus B, and A minus B, and A minus B. I took 5 examples. I request you to do it for B minus C. So whenever you make a note of this one, simultaneously make a note of B minus A itself. Yes, you can please proceed. So we are done with 2 differences. One is A minus B and another one is B minus C. So first one union, second one intersection, third one we have 2 sets. One is A minus B and one is B minus C. What happens when it is A minus B minus C? If we talk about 3 sets, A minus B minus C. In case I have A as same 1, 2, 3. Let me go for a small example. B as 1 and 2. I have also C which is 3 and 4. What happens? A minus B. First let me do A minus B because we are strong in A minus B now. What is A minus B? 3 alone. What is A minus B minus C? First I worked out on A minus B which is 3 minus C which will be null set. Am I right? Because I'm not going to talk about 4. It's present only in C. It's not present in A. Okay. Now we have to work out the same on Venn diagram. So you're strong in Venn diagram? Hope so. Okay. Yes. We have 5 different cases. What are the 5 different cases we have? Case 1, case 2, case 3, case 4, case 5. So I'm going to work out this one for difference, which is A minus B, right? This is full for A minus B. Then the fourth set, difference for B minus C. Will you try working out? Yes. Yes, please join. Third one, A minus B, which means actually we are writing this as only A, correct? Only A. So we have to shade only A, which means if you please make a note, the center region, no, this is not present. Am I right? Second one, this is the region, right? So what is here? A minus B will be A itself. Hope I'm right. Yes. What about the third case? Huh? Empty set. Because A is properly contained in B. It's a subset of B. So when I talk about A minus B, it will be a empty set. So we use this representation for empty set. Fourth one, A minus B, we'll get this region. We'll be calling this as steniquate ring. Okay. Else you can call this as donut. No, ma'am, we don't understand. Whatever. Now you can understand. Which means we make a hole. This is a hollow space, which means there's a hole. So the space is not present. Yes, fifth case. What is A minus B? We already know about this fifth case and first case are both same. Only thing present is C. We not worry about C. Again, we are going to talk about A minus B only. We are not worried about C. So you take the whole of A, but not B. What about C? You have to take C or not? You have to take C. Because C is present, I am making a noting on A minus B or A. I'm not talking about C. Okay, so C will be present, B will not be present. Okay, right? Shall I go for the fourth case? B minus A, just the reverse, right? Just check whether I'm doing it right. My shading is right. Yeah, what is this? A minus B, sorry, B minus A is B itself here. This annular ring like, this is like a ring like format will be, okay? And here empty set. So in this case, B minus A will be null set, and here whole of B where C will be included. Hope it is okay. Okay. Shall I go for the next set? So that's about difference now. So next set, let me discuss here itself. What's the name of the operation? Symmetric difference. What do you mean by symmetric differences? We consider both the unions, okay, which is denoted as A del B. Okay, A del B. Sometimes in some material you can find this symbol also, but usually I use this triangle symbol. Okay, so this is symmetric difference A del B, which is you consider A minus B. Also you consider B minus A. Then you take the union of both, which means you consider the third case, you consider the fourth case, then union of both. Yes, can you please try? Yes, please. Please check my shading. This was A minus B. This was B minus A, right? You can clearly understand this common area will not be present. Then this case, this was A minus B, this was B minus A. So when you find that A and B are not overlapping, disjoint set, then this A del B will be nothing but A union B itself. Am I right? Then third case. Third case is A is contained in B. Yes, what's the shading? A del B. This one and this one union. This is the case where you got empty set. This is the case where you got the ring. It's union, right? So either A or B type. You got this one right? Yeah. Fourth case. Yes, fourth case. Same this one. Right? Correct? Huh? Able to get it? And here whole of A, sorry, that A part alone and B part alone. See, you need not worry about C. C may be present, C may not be present. Okay. So this is the fifth case. Is it okay? Shall I go for the last case? Last case I have already discussed. With respect to complementary, we'll make a fast marking complementary set or operation regarding complementary. Yes, what is A dash? So how we represent is A dash. We shall write it as A dash or A bar, or we shall write it as A like small c. So A complement, okay? Write it over here. Yes, can you please try? What is A complement? Not in A. How you represent A complement? Not in A. This is what A complement is. Yes, please. Can make please join with me. I'm talking about not in A. There can be any number of sets, A, B, C, D, whatever it is. Your picture in mind should be this is the universal set of the sample space, there is only A. There may be B, there will be C, we not worry about that. Okay. What is A complement? We are saying it's not in A. So what will be your shading? This will be a shading, right? Okay. Have this concept in your mind and try working this one here. Yes. Can you join? Not in A, which means in this case you need not worry about the B overlapping with A. A should not be there. Need not worry about B. So what happens here? You can shade this one. Am I right? Please check. See, I'm striking out B, but not whole of B because this region which I'm trying to circle out here is present in A also, is present in B also. Okay, please try to note. Present in A, it's present in B, but my intention is to go for not in A. So this common region will not be present. So you need not worry about B. Okay. Yes. So this region completely which I'm shading is not in A. Am I right? What about here? What is A complement? Am I right? No, I'm not right. What is A complement? A should not come. I have to shade this one also, right? Is it okay? Is it okay? Am I confusing you? Or you're getting confused? If you're getting confused now, you are studying in a right way. It's very clear. What about here? A should not come. That's it. Am I right? You need not worry about the other areas, but A should not be present. That's it. What about here? Am I right? Which is A? The outside part is A. This is B. Okay, the outside part is A. So the outer region. What about here? The same case as first one, right? So I'll be shading all these regions. Is it right? Please check whether you can manage, and please also check whether you got everything right for all the six cases. I'll just make it as a single page. See, I have made it as a single pager. Probably in your notebook, it will look like this. Please check whether everything is okay. If any doubts, we'll clarify immediately before going for continuing the concept. The concept is not yet over. I have to continue the concept still. Yes, please. How we have represented the set is A equal to, remember, first it should be in caps. Okay. Then we'll have an equal to sign. Then the third part will be you'll open a bracket, you will close a bracket, then you separate by commas. This method is what you call as listing method. Why you call this as listing method? Now you just list it. But for this element to be present in the set, we need to have a rule. You remember the very first definition, how we defined what is the difference between a group and a set? When I say it's a group, just I'm putting everything together. It's like a crowd of people. When I say it is a set, it will be following some common constraint or common rule or something like that. So there is a rule present, right? How we represent this one is A is equal to, we open a bracket, close the bracket. We take this as two parts. Okay. And we separate by a colon. This colon, in English, it is a different meaning. Here in mathematics, when I present this colon, after this, there is a condition present. So I'm going to have the condition over here. And before this colon, I'll be naming it as, normally we represent as X, which means X is the member or element of A. This is how we present it. Member or element of A. For example, we are talking about set of vowels. An easy example is set of vowels, no? What are the set of vowels we have? A, E, I, O, U. And I'm naming this as A. This method is what we call as listing method. But I'm now talking about the rule method. In rule method, we'll be presenting this as A is equal to, okay, open the bracket, close the bracket, X, see, what is this here present? X, and the condition after this, you will not call this as colon, you call this as such that. How you read this is such that What is this X? What is the nature of X? It can be A, it can be E, it can be I, it can be O, it can be U, which means it's a vowel. So, such that X is a vowel in English alphabet. Is it okay? Is it okay? How you read this? Let me put it in quotes. A is a set of all X. See, this is X. Such that is this colon. Such that what's the condition? Condition X is a vowel in English alphabet. Is it okay? So this is how you read it. A is a set of vowels that's in descriptive form. Here I say A is a set of all X such that X is a vowel in English. Okay. Yes, if you want to make a note of it, please. So we're going to represent the union intersection in terms of rules now. Just the actual definition. Okay. Like to continue? What happens here? Let me go in detail with respect to union. We can manage with intersection and other things. Okay. So we'll go in detail with respect to union. How we have written union in terms of wordings? Either or. Either A or B. What is the symbol we are using? U. We are talking about A and B. So A union B. So A union B is equal. This is the name of the set now. A union B is equal to, open the bracket, close the bracket. This one will not change. Usually this is a common representative. So X is an element such that X is present in X is in A, either A, right? X is either in A or B. Is it okay? This is how you write it. Can you just imagine for intersection? Set of all X such that X is in A and B. Remember, intersection is and. See, we use a symbol for representing an element. The symbol is what you call as epsilon. How we call the symbol? Epsilon. We read it as belongs to. How you read this one? Belongs to. So when I say A, E, I, O, U, and I represent this as capital A, I say that A, small a, this A, small a, belongs to capital A, which means it's a member, it's an element present. Is B present in A? So we write this and strike out. When I say equal to, not equal to. Same like A belongs to A, B does not belongs to A. I write this as B does not belongs to A. Does not belongs to. Okay, not it over. Let me finish it off. I'm going to represent, I'm going to take the help of this symbol over here. Yes, how can I represent? A union B is equal to, open the bracket, close the bracket, set of all X such that A belongs to A or A belongs to B. Am I right? Please make yourself confirm. Is this clear? A belongs to A or A belongs to B. Am I right? Am I right? Okay, shall I continue for intersection? A intersection B is equal to set of all X such that X belongs to A. Instead of or, what you'll get now? And X belongs to B. Only difference is here or and here it is and. Is it okay? Now I'll fit all these things in that main page. Yes, ma, please join with me here. Union, the symbol is this U. So I can write this as A union B is equal to set of all X such that X is either in A or B. Is it okay? Or I shall represent this as A union B is equal to set of all X such that X belongs to A or X belongs to B. Hope it is clear? Continuing for intersection with no delay. A intersection B, what's the symbol? It's inverted U. A intersection B is equal to set of all X such that X is in A and B. Okay. So if I represent with the help of epsilon symbol, X belongs to A and X belongs to B. Third one, shall I continue? Third one, A minus B, which is equal to set of all x such that, what is the wording we use here? A minus B. A minus B. Only in A. Such that x is only in A. Yes, with the help of epsilon symbol. A minus B is equal to set of all x such that x belongs to A, but which means it's a condition, strong condition. And but means and here. And x does not belongs to B. Am I right? What is A minus B? It should be in A. It should not be in B. See, that's what A minus B is. So A belongs to X belongs to A and X does not belongs to B. Yes, you can join for B minus A. B minus A is equal to set of all X such that X is only in B. Okay. Also, I'm not finding space. Let me write it little small. Set of all X such that X belongs to, first I'll go in order, A first. X should not be in A. So X not in A and X belongs to B. Okay, hope it's clear, Nanikra, right? Then fifth one, what is A minus B? What is A del B? It's simple. A del B. A del B. Set of all X such that X, should I go for the symbol wise? Belongs to A minus B or union, right? Or X belongs to B minus A. Is it okay? Then sixth one, A complement or A dash, A bar or A complement can be written as set of all X such that not in A. So not in A can be written as set of all X such that X does not belongs to A. Is it okay? What about this one? I have written only one format. Shall I take this space for writing? A minus B, A del B. Yes, I have not written in wordings. Set of all X such that X is either in A minus B or B minus A. Is it okay? See, whenever I find union, I'll use either or. Make yourself sure. Either in A minus B or B minus A. Okay. So I request you to make a note on the same page, single page. Make it as a single page because it's very, very important. We'll be highlighting in future here. We'll go for theorems. Theorems on sets. Named as addition theorem on sets. Addition theorem on sets. Okay. Please remember, when I use the term addition, it's not a union or intersection. It's about what? It's about what? Addition. It's an arithmetic operation. Okay. Also remember, when I talk about addition, it includes subtraction also. Okay, many will have this doubt. How it will include subtraction? When I say 2 plus 2, actually what you're doing? Okay. When I say 2 minus 2, actually it's not 2 minus 2, it's 2 plus minus 2. Actually, this is a negative number. When you take a negative number for addition, it becomes subtraction. So addition and subtraction is same symbol only. Symbol wise is different, same logic only. Okay. So I'm talking here about addition theorem on sets. So we'll be using plus and minus. But when I talk about sets, I need to talk about operation on sets. We'll be using only two operations here. One is union and another one intersection. And the focus is on not about directly on A and B. We are not going to talk about sets. We are going to talk about the cardinal number on sets. You remember what do you mean by cardinal number? I was discussing in the earlier session. What is cardinal number? We represent using small n. If A is containing 1, 2 and 3, then n of A will be number of elements in A, which is 3. 1, 2 and 3. If I have my B as A, B, C, D, then what is n of B? A, B, C and D. 4 elements. Is it okay? So here addition theorem on sets will be on cardinal number. Okay. So we have two cases. Case 1, case 1, n of A union B is equal to n of A plus n of B minus n of A intersection B. So this is one theorem. I'm not going for the derivation part. Then case 2. So this is on two sets on A and B. In case if you have three sets on A, B and C. I have three sets A, B and C. Then n of A union B union C is equal to the whole of A, n of A. The whole of B will be n of B plus n of C. Okay. See, what I did over here is I took the whole of A, whole of B. For A and B, A union B, I took whole of A, whole of B. Likewise, I have three sets A, B and C. So I take whole of A, whole of B, whole of C. What I did next here, I removed the common part. So here it will be minus n of A intersection B minus n of B intersection C minus n of A intersection C. How can you remember this one is I have A, B and C. Remove the common between A and B. So this is A intersection B. Remove it. So minus. Removing means minus. And here B intersection C. Remove it. So minus n of B intersection C. And here it is C intersection A. Actually C intersection A and A intersection C are both same. So remove it. In addition to that, you have to remember one more term plus n of A intersection B intersection C. What happens here is when you remove A intersection B, common thing is removed. Here also common thing is removed. Here also common thing is removed. But ultimately there will be one element present. So that's why we have to add back this one. I'll place a star mark because you should not forget this one. So let me repeat here. We have n of A, we have n of B, we have n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C or C intersection A. It's same. You have to add back. See, it's a plus sign over here. Please make a note. It's a plus sign over here. N of A intersection B intersection C. Is it okay? Can you try a problem on this? You can take it as an assignment. Can you try a problem on this? If I give A as, I'll go with numbers 1, 2 and 3. B as 3, 4 and 5. C as 3, 6 and 7. You have to try working for case 1 and case 2. N of A union B you have to work out. N of A union B union C you have to work out. So what you'll do is probably if you go for case 1, I need to find what are the things present here. Can you please help me out? You have to find A union B. What is A union B? 1, 2, 3, 4 and 5. What is A intersection B? 3 alone. So you have to check left hand side and right hand side and you have to check whether they are both equal. So can you do this for case 1 and case 2? You can take this as an assignment. Okay. So that's all for today. We'll meet in the next class. Almost the theory is done. Probably I have to highlight everything. Probably next class I may be finishing it.